What if I told you humans built a bridge higher than the clouds? This engineering wonder stands 565 meters above the river, surpassing the Eiffel Tower. It is a bridge where planes fly underneath daily. Driving across feels like floating through clouds with nothing but air below. Before this bridge, crossing this gorge took 5 brutal hours on mountain roads.
These cables hold 10,000 tons of steel suspended in midair.
I am standing where engineers once claimed nothing could ever be built here.
Guizhou Province was one of the most isolated places on Earth.
Millions lived cut off, with no highways or fast routes.
Guizhou had no expressway at all until the year 2000.
The government made a bold decision to connect the region regardless of cost.
The problem was one massive gorge that stalled plans for 13 years. Why not just build a regular bridge? Let me show you.
Every traditional design failed at the drawing board due to the extreme terrain.
Engineers spent 2 years studying the gorge before a single design was approved.
The wind data was terrifying, with gusts reaching 140 kilometers per hour.
In 2011, one genius engineer finally proposed the design that would work.
This blueprint was the key. A cable-stayed bridge using towers built on cliff ledges.
Construction officially began in November 2011, and the challenges started immediately. Some ask how workers even got down there to start. Every anchor point had to be drilled by hand into solid rock. The site was so extreme that normal cranes could not work. Engineers designed a custom cable system just to move equipment across the gap.
A road had to be carved directly into the cliff itself before anything could be built.
They used 200 controlled explosions to clear the cliff face, all perfectly calculated. After every blast, geologists inspected every millimeter of the remaining rock for weakness. 2 separate teams built from both sides of the gorge simultaneously.
Each foundation anchor was drilled 15 meters deep into solid bedrock.
I can feel the vibration through my boots as they drill this rock into submission.
After 8 brutal months, both foundation pits were finally ready for concrete pours.
Each pour required 15,000 cubic meters of concrete, poured continuously.
They could not stop the pour. One crack in the foundation and everything fails.
Inside is a steel skeleton, so dense you could barely walk through it.
Each tower had to grow from the cliff edge, not flat ground. They used a self-climbing concrete form, rising 4 meters every single day consistently. Now you might be thinking, how do workers stay safe that high up? Every worker platform was fully enclosed to protect them from the wind.
Looking straight up this tower gives you instant vertigo. And it is not finished yet.
Tower 1 reached 100 meters in just 62 days, breaking records as they built.
Every meter upward required a laser check. 1 degree off, and everything gets scrapped.
While Tower 1 grew, the team on the other side was 40 meters ahead.
Winter hit them hard in 2012, but work never stopped despite the freezing temperatures.
Inside each tower is a system of pre-stressed cables holding the concrete under compression.
Every computer simulation showed the same result. This design could handle anything nature threw at it.
The tower tops were now level with the gorge rim itself.
The final tower cap had to be placed within 5 millimeters of the exact target position.
Both towers completed in 18 months, 392 meters of concrete rising from cliff edges.
Each tower top holds 56 cable anchor points, engineered to handle 4,000 tons of force. After 18 months and 2 towers, the gorge was still empty.
The cable installation phase was the most technically complex part of the entire project.
56 cables per tower carry the deck weight directly to the foundations.
Each cable contains 109 individual steel wires, all twisted together under precise tension. After 18 months and 2 towers, the gorge was still empty.
The pilot had to hover in 80 kilometers per hour crosswinds while workers attached cables.
I am watching a helicopter thread a steel cable across a 720-meter gorge. Absolutely incredible.
Every new cable changes the tension on every existing cable. Each cable is tensioned to within 1% of its target load. As cables tighten, they literally pull the deck sections upward into alignment. After many cables on each side, the bridge started looking like the harp of a sky giant. The cables started singing in the wind, creating dangerous vibrations.
The tower tops were now level with the gorge rim itself.
The solution they found that night was elegant. Dampers installed inside each cable housing.
Viscous dampers, basically giant shock absorbers, were fitted to every single cable installed. Before and after comparison, the dampers completely solved the problem.
56 cables on Tower 1, all tensioned, all dampened, all perfectly aligned.
Every cable was inspected centimeter by centimeter before the next phase could begin. 112 cables stretching across the Baypon River Gorge, one of engineering's most beautiful sights. When the final cable clicked into place, grown engineers were literally hugging each other and crying.
4 months to install 112 cables, each one a lifeline connecting man's ambition to solid rock. The deck had to be built from both towers outward at the same time.
I just stepped onto the deck and I can see straight down a great distance through a gap.
Each deck section was prefabricated off-site and flown in by the world's largest cranes.
Every single bolt was torqued to a precise specification, then checked twice by inspectors.
The welding was done 565 meters up, with nothing below them but a thin safety net.
What happens when those two arms finally meet in the middle?
Every meter the deck extended, the stress calculations had to be recalculated from scratch. Inside the deck is a sealed steel box. Inspectors crawled through it, checking every weld.
Some days the wind hit 120 kilometers per hour, but work stopped for nothing.
Both deck arms grew simultaneously, and the closing gap became the countdown everyone watched.
When they measured, the two deck ends were 3 centimeters misaligned.
By adjusting tension in 12 specific cables, they moved the entire deck into alignment.
After 18 hours of micro-adjustments, the two deck ends were aligned to within 2 millimeters.
The closing piece weighed 120 tons and had to drop perfectly into a 120-ton shaped gap.
When that closing piece landed, the two sides of the gorge became one for the first time ever. Every bolt team was synchronized by radio, 200 workers all moving at the exact same moment.
The workers started calling it the day the gorge disappeared forever.
I am standing in the exact center where the two halves joined. This moment changed everything here.
1,341 meters of steel deck. Completed in 10 months, the gorge was defeated.
Before roads could be built, engineers laid a 20-centimeter reinforced concrete base first. Paving the bridge took 6 days, working 24-hour. They never stopped until it was done.
Every safety system was installed simultaneously. Crash barriers, lights, lane markings, and signs.
Inside the deck is a sealed steel box. Inspectors crawled through it, checking every weld. In Guizhou's climate, the bridge steel expands and contracts by half a meter every year.
This bridge has 600 embedded sensors. It reports its own health data in real time, always.
Every sensor reading goes to this control room. Engineers monitor this bridge like a patient's heartbeat.
Some ask how you test a bridge this big. Like this.
80 trucks loaded to maximum weight drove onto the bridge at once. The deck deflected 45 millimeters, exactly what the computer predicted. The model was perfect.
They then made trucks drive at different speeds to test dynamic vibration response.
The wind data matched predictions exactly. Years of research validated in one day.
When they turned on the lights, villagers in the valley below stopped and stared.
Standing on an illuminated bridge floating in darkness, this is the most surreal moment of my travels.
Before opening day, inspectors walked every centimeter of the bridge, checking everything by hand.
December 29th, 2016, the day that changed Guizhou province forever, had finally arrived.
They said it was impossible, then they built it anyway. Like, share, and subscribe.